I'm glad you're here. I'm going to talk about a bunch of things that we, Liferay, as members of the OSGi Alliance, have been working in the Alliance to kind of evolve OSGi, make it better, just to improve the developer experience, which is one of our mandates, as Augé mentioned in the keynote. We want to make developers' lives easier. Liferay is founded on a lot of OSGi technologies, so improving those technologies leads to improved Liferay. So let's start. There's quite a bit of information here. It's going to be a blast through a lot of information, but what I'm hoping is that if you see something that interests you, you can come and talk to me after for more information about that, and I can either point you at specification work, or we can just talk about it, and I can answer questions, and that's how I want to kind of tackle it. So, fundamentally, in the bottom of a bunch of the OSGi, of all the OSGi specifications, is the definition of the module layer. The module layer is the part of the OSGi framework that deals with all the dynamics, all of the bundles, the jar files, the class loaders, and all of that stuff that hopefully you never really have to think about much. But some of the information is useful for you. You put metadata into, you probably know that in order to get an OSGi bundle, which is distinctly different from just a regular jar file in one particular way, which is that it just has more metadata in the manifest file. And so starting at that very low level, a couple of new additions are some new manifest headers, just to bring parity to the information you probably traditionally have seen inside POM files or Gradle files that kind of list out the developer and the SCM information. So here's a couple examples of two new headers that were added to the module layer so you can put more information. Now, really cool addition, and this is more for the tooling side of things, is that there's a bunch of new build time annotations, and these are intended to be supporting by tooling, which allow the developer to, rather than encoding the information inside a text file in the manifest, you encode this directly in your Java classes, in your Java package file, package classes, and you can store the information there. You can make meta annotations out of these, and it just makes it a really nice way to put typed information that will lead then to metadata, and annotations really just make this a lot easier to deal with. And it makes it much portable for developers to reason about. And here's an example. So there's we sometimes want to add custom information to bundles, our own metadata headers. So here we have an example of using this new annotation headers, which is a grouping of header annotations, which you can put arbitrary information into. And here you see it applied to an interface. In the second example, we're using two other annotations, which is designed to define a new capability that we want some of our code to expose. And if you're familiar at all with OSGi, how it works is really it's a bunch of requirements and capabilities that get resolved by the resolver at runtime. And you see then we created an annotation out of meta annotations, and we're using it. So that's some low-level stuff. Now on to kind of a little bit more of the stuff that we use on a day-to-day. Logging in OSGi has traditionally been kind of a sore spot. In most cases, we've kind of resolved ourselves to promote the use of just use standard logging from some standard library, and then we'll adapt that in a different way. So use commons logging, or probably a better choices would be log4j or SLF4j, and just use that in your bundles, and then we figure out a different way to wire the implementations in. And there's a bunch of different projects that do that, right? And however, a really nice addition in R7 is going to be a better logging API right in OSGi from the get-go. And here you have what you'd expect, kind of like in the SLF4J model, right? Which is a factory that produces a logger instance, and then that's a named logger instance. It's hierarchical, and as you can see in the last example here, we're using SLF4J style replacement. That's really nice. On the other end of the logging story is consuming log events, right? So there is a new specification in OSGi, which is called push streams. And transparently here, what you're seeing is a log provider that's got a functional stream-based asynchronous mechanism for receiving logging events, so that in these 3 lines of code here actually builds that up completely. Uses the log stream provider service that it got from the service registry. It creates a stream of the log events, and then you just process each one of them. And this is an asynchronous, evented, completely stream-based processing cycle, and it's really, really easy to use. Then we have the log service management APIs. Here we've added a declarative and programmatic mechanism for configuring log levels, because simply using the log levels isn't always the whole story. You sometimes need to do some some tweaking, maybe at runtime, maybe through configuration files, and we support both of those things. OSGi R7 will support both of those things. And this is seamless integration with configuration admin, if you're familiar with that. So you can configure the logging through configuration admin, which is a really nice integration. Next, some changes to the configuration admin service. Here we've added several different features, notably named factory instances. If you're at all familiar with like a file install configurations of factory instances, you basically named a text file with a particular format in order to get some new instance from your service factory. However, that name didn't kind of relate anywhere into the system, and this addition makes it possible that you can use your own name to assign to a particular instance. This makes it possible to, have a foreign key relationship between a configuration and some object in your object model that relies on configuration, for instance, or even just applying user readable and understandable names to different configuration instances. Read-only has been added, so you can have read-only configurations. Passive update, which is that you might have a system that wants to make sure that configurations are up to date with an external system. And so there's a passive update. So update if different, which just checks to see if any changes are there. And if there's none, then it just does nothing. So it's a safe way to just basically enforce that everything's up to date. And lastly, configuration admin service has this plugin mechanism. And in order to enforce that these plugins are called at the right time, a new method was added in the API so that consumers of the API could make a call to ensure that those plugins had been called. And this is useful for doing things like encoding encrypted passwords in configuration files and whatnot, calling replacers that would just logically replace system properties with replacement syntax in your configuration files or whatnot. So really handy for doing those kinds of things, which are important. Moving on to declarative services, really, really great addition here is activation injection, or what you probably prefer to know is that it's constructor injection. So if you've ever used declarative services, adapting existing object models into declarative services can sometimes be a difficult task, because there was no way to reuse objects that needed to be created from a constructor into a declarative services component. And so because now we have constructor injection, you can push your service references directly in through the constructor. You can also add references in the activate method, which is also very nice. And then finally, a really nice integration was created with the log service so that when you use the last scenario here on the bottom, if you just simply refer to a logger as a service reference, what you actually get is a named logger for the component class that you have. So this is really, really nice. With this one line of code, you get a nice a named logger for the component in question. Next in Declarative Services, we have some more additions, factory properties. If you're at all familiar and have delved a little bit more deeply into some of the more complex declarative services scenarios, you probably know or may not know that there is a component factory function built into declarative services. So you can programmatically create instances of components. However, there was no way to configure the properties that would be bound for those instances aside from calling API. So this was added to the component annotation and to the metadata of the components so that you can specify the factory properties. And then finally, this what you'll see repeated in a lot of the specifications here is a service.changeCount service property. And where this is used is in diagnostics systems or an evented way to detect that different OSGi subsystems have been modified in some way. So an example here is you're running a test, you're deploying a bundle in your test, and you need to know when the components inside the bundle have been picked up by declarative services so that you can then call them or make assertions on them or make sure that things have been wired up properly. And so declarative services has for a while now had a service component runtime, which is a service that you can access from the service registry in order to observe the object graph that SCR has for any particular bundle, so that you can actually introspect the components that exist in a bundle. And because the service change count is being updated whenever new changes are made, you can monitor. Here you can see that I have a reference which is using update strategy. Whenever that updates occur on the service properties of the service component runtime, I'm just going to get bound to a new service, and then I can then do cool things like verify that the service I'm interested is there, and then, maybe using promises or something like that, execute my test. So without writing wait logic or, looping over a while thread sleep kind of mechanism, you can use an evented mechanism with, some kind of timeout, which we'll show an example of later on the service component runtime. So it's a lot nicer. And then finally, declarative services, while being very, very useful and very powerful, had this sometimes bothersome mechanism that you could configure the service properties inside your component, and however, those were all string-based arrays. And so if you had anything complex in there, there was a potential for types, string, typos in your strings and whatnot. So component property types were designed to solve that exact problem. And so you can create an annotation which is meta-annotated with component property type, which you can then use on your component and basically define a service property and then apply it in a typed way. And the second part of the example here is a component annotated with my custom annotation that I created called config, which has a field called name, which has a string. And then there's some standard component property types that are delivered with the framework now in R7 that you can just use. So for instance, if I want to apply service ranking on my component, I just need to use the service ranking annotation, and I actually put an integer value in there instead of trying to use the funky string encoding for service ranking. Really nice. And yeah, so there's a bunch of standard ones of these, and there's, of course, you can build your own. Next, JPA Service is being updated. It's being updated to support JPA 1.2. JPA 1.2, if you're familiar with it at all, standardized a bunch of configuration properties for defining your entity managers and or your data sources. So those are standardized things, like your password and your username and the pool sizes and timeouts and things like that. So all of many of those were standardized. So those were included in the specification to make sure that those were supported. And then because there are standard properties, a life cycle for the updates of those properties had to be added into JPA so that when you modified those properties, you could understand what that would translate to in the sense of how that's going to affect all the modules that you have that are integrated with the JPA services, like the entity managers and whatnot. So when the configurations are updated, there's a proper life cycle related to all of those objects so that you can tear down and reconstruct safely, and it's all well defined. And finally, in order to properly support XA, or distributed transactions, there was a little bit of information that was missing, that was making it very difficult to integrate well with all of the different persistence providers out there that supported XA. And so a couple of new methods were added here to support that use case. Really, really low level now is the resolver service. The resolver service is used whenever you deploy a bundle into the OSGi framework, or during build time when you're using a resolver mechanism to make an assembly of artifacts that represent your application. There's a bunch of different concerns that weren't quite clear in previous iterations of the spec. For instance, how do you deal with fragments? How do you choose the right fragments to belong inside the set of bundles that you want to use? And the next one is substitutions. OSGi has this notion of substitutable imports. I won't get into it. If you want me to explain what it is, I can talk to you about it after, but then we added a method to add support for observing what substitution wires were created. And thirdly, a cancelable resolution callback, so that if you had a long-running resolution or something happened, there was an on-cancel callback that you could hook into to discover whether you should, retry your resolve operation, or change the inputs for the resolve operation to narrow the set of requirements or anything to that effect. And then finally, if you've ever used dynamic package import in your bundles in order to do imports that were kind of weird and that B&D couldn't necessarily resolve, or you're trying to use a scripting engine and you need to import the world, these things happen at runtimes, and there was no well-defined way to describe how the framework should handle the resolution of dynamic imports. And so a new method was added to kind of add support for that, so you could explicitly be calling that behavior. Into the more probably interesting stuff for the average OSGi developer, Http Whiteboard, which is a really, really nice mechanism for using servlets and filters and that type of thing in OSGi. We have new standard component property types. That goes back to what I mentioned in Declarative Services earlier, which is a bunch of standard annotations so that you don't have to put those long strings inside your properties anymore. You can use actually typed annotations to put all that metadata in. Very, very nice. And further to that, multi-part support was added since multi-part support came in Servlet 3. And HTTP Whiteboard supports Servlet 3. We added multi-part support. So you can do file upload using the Servlet 3 API. And this is just a configuration for that behavior. Next, in HTTP Whiteboard, we added something called servlet preprocessors. Preprocessors are basically, if you ever used Tomcat way back in the day, there was this, before the filter chain, you could invoke, I can't actually remember what they were called, but there was an integration point that would execute before the filter chain executed. And that was a really convenient way to add global kind of decision-making before the dispatching starts. And so that was added into HTTP Whiteboard, called preprocessors. They behave exactly like filters, except they're guaranteed to run before the authentication phase happens. So this is a really good place to do global kind of higher order or lower order, actually, calls into integration frameworks for SSOs and things like that, or even to just add things like diagnostics or auditing into the framework at a global level. So you capture everything, or you can capture everything from there. And then finally, there's a control for executing the security check. A method was subsequently added to be able to detect the end of that security context. So at the end of, you've decided that your security context is valid for the request, and a method was added to kind of capture the close of that. We've finished, and now you can do some cleanup. So a finished security method was added to the Servlet Context Helper API. So similar to Declarative Services, where we added a change count was added to the HTTP Whiteboard. And then this is, again, so you deploy your servlet into the service registry, but you're never quite sure when that's actually endpoint is available. So the service change, the HTTP Whiteboard's runtime will get a service change count update when any change happens, so you can kind of detect this. You can detect in an asynchronous way that you did something, and the HTTP Whiteboard is reacting to that. So then you can determine, okay, you can check, is the DTO inside the object graph for the service runtime? Okay, yeah, now I can go ahead with my test. And that simplifies that whole asynchronous behavior. So you have an evented way to detect those changes. And then you have component, we have, again, HTTP service integration. That's in about the fifth line or fourth line of the second example here, which is integrating legacy HTTP service API with the HTTP Whiteboard, which kind of some people wanted, so that was added as well for convenience. I'm not going to go through transaction control service very much because I don't have a lot of time, but suffice it to say, it's a brand new portable modular transaction lifecycle API built from the ground up with a functional kind of design. And it's really, really interesting. So if you're doing transactions at all in OSGi and you're suffering the pain of trying to use JPA and you just want to go to something simpler, I would suggest looking at this new specification. It's really interesting to use. And it covers all the different use cases. Here's just one example of a required transaction scope, and then executing some operation, and then doing proper cleanup and whatnot. That's just one example, but there's tons of all the use cases that you'd expect are covered here. So it's really suggests you looking at that if you're doing JPA. And so here's a list of kind of all of the aspects and concerns that are addressed in that transaction control service API. So XA and adding resources into transaction manager scope and all of that stuff. Then another subsequently new specification is called cluster information. This is all about you have a cluster of nodes. They have you have Liferay spread all over the place. It has OSGi frameworks running everywhere, and you want to basically introspect information about that, as a whole. And so a cluster information specification is created that publishes services into the service registry about the nodes available in your cluster, so that you can introspect all the information, the IDs and the country and the location. If you're a multi-data center, you can use zones and you can use tagging to identify different services, which service is running in that particular framework. Is it my search engine? This one's my database, and so on and so forth. All of that information can be encoded using these properties. And then on top of that, there's a way to kind of get metrics specific to the environment that is there. So there's a way to extract specific metrics for that, for those particular nodes in the cluster. Further to that, we have a framework node status API, which is a service in the service registry for each node in the cluster that you can use to actually manage that remote framework. So that's very nice. You can, kind of get a view of your whole cluster, and then you can perform operations like install bundles, stop them, and so on. Configurator is a really nice new specification for handling configuration, so that this is kind of like a specified, standardized way of using resources to configure your framework. You've probably seen that Liferay uses Apache Felix file install for configuration files, and this is just a specified version similar to that. It's a way that you can put configuration resources inside bundles, deploy those, and then there's a lifecycle behavior on how those configurations get added to the system and are managed and whatnot. And it has an encoding, well-defined type system that's well-defined. It uses the extender pattern, it's UTF-8, it's JSON, it's all the really cool things that we want that we never had in OSGi for doing configuration. And you can even pass all of this stuff in through service system properties. So it's really nice. You can pass in all of your configuration through system properties, either by directly passing an encoded JSON object, or you can just point to a bunch of files. So that's really, really nice. Very nice for CI and for deploying to the cloud, where you have different configurations than what you might have on a test machine. And here's an example. You can put binary information in these resources, or you can point to binary information. So all of your keys, your public-private keys can be there. All of that stuff. It's really nice. JAX-RS Whiteboard integration. I'm proud to say that Liferay was the implementer of the reference implementation. It is in the Apache Aries project, but Liferay was the implementer, and I'm really proud to say that we're almost done, and this is just about ready to go. And this is going to be a feature in the next version of Liferay, which is a real JAX-RS OSGi integration, service-oriented assemblies, and here's an example, the annotation-based configuration, all of the really nice stuff that we get with declarative services and dynamics, all of that, and then JAX-RS. So yeah, all the different concerns there, requiring static extensions and requiring extensions and static resources and multiple whiteboards and all of these really cool things that help you build complex systems out of really nice reusable small pieces. Promises API. This has been there since R6. This is really nice. If you haven't used OSGi promises, this is one of the specifications you can use outside of an OSGi framework. So if you're using futures or any of the asynchronous features in Java 8, you might want to take a look at this because it's a really nice, functional, simple way to do asynchronous programming. It's designed to follow the JavaScript promises pattern, and it's really, really cool. You can do delays, timeouts, callbacks, all of that stuff. It's really, really nice. Push streams is an asynchronous data processing API, which is, again, one of the OSGi specifications that you can use outside of Liferay. This is for doing all of your async data processing, and very, very interesting. Lots of really cool stuff to be done with that. Last but not least is the converter specification. We're always converting data from one type to another. We're reading parameters and then casting it and trying to use, convert this parameter into a long or, an array of longs. And the converter API standardizes a bunch of those conversions, and you just use it. Or if you're looking for something that's slightly non-standard, you can create your own rules to go off of what the standard is. So you can build your own converter instances, and then here's a bunch of examples. So Lots of really cool stuff in OSGi R7, something for everybody. I suggest you take a look. The latest draft specification isn't going to be out till, I think, next week, but once that's there, I'll make sure that some tweet goes out that you are informed about it, and then you can download the PDFs and take a look, and there should be something for everybody. And that's it. That's a whirlwind tour. Thank you.